Okay, here I'm going to do uh, here I'm going to make a non-covalent interaction map for this structure here using the multi-wave function approach. So this is my structure that I'm interested in here, and I want to try to see all of the non-covalent interactions, or NCI here, but most interesting in our present case is this hydrogen bond. So I want to kind of get an idea of the strength of this hydrogen bond here, how attractive this is relative to another acid species here. So what we're going to do is we're going to map this for kind of a qualitative analysis. So the first thing is I already have an optimization and a frequency performed for this calculation. And once I have that, I take my output geometry from this and I make a new calculation here. The purpose of this calculation here is to create a .wfn file. This will serve as an input and will contain the electronic data that multi-wave function will open up. So you can see the output here, or up in the route section, I have out equals wfn, and then below the geometry, I've specified a directory and the file with an extension for the final file. So this ended up taking about 2 hours with this method, with this TZVP method, and it's done at the same level of theory that my optimization and frequency was done at. So once this is done, we'll take this .wfn file and save it somewhere where you can use it, and then we'll open that file with multi-wave function here. So here's multi-wave function. I open a file, and we'll load up our WFN file here. Here it is. And once that's done, we're going to select option 20, visual study of weak interaction. So we select 20 here, and we're going to do this first option, 1 NCI analysis, and it has this Jack's paper from 2010 as the main theory portion. So we'll select 1, press enter, and now from here you have a couple of choices. So far what I've had success with is we can select a medium or high quality grid, and that will define a cube around the entire system. So you'll get all of the NCI. The other option is to go back to your index here, and since I said we're only interested in this hydrogen bond, we can select, say, these two atoms here, and the midpoint between these two atoms will be defined as the center of the cube. So here, let's try that one. We have the atom number 2 and atom number 30. So what I do first is I'm going to do this other option, 7, the same as 6, but input 2 atoms. The midpoint will be defined as center. So we'll do 7. My atom indices are 2 and 30. So I do 2, 30, press enter. And now I define a number of points. So I think that this number of points kind of defines the density within that cube that we're going to specify. So a good starting point that gives pretty good results is like 40, 40, 40. I tried 100, 100, 100. That was pretty good. So this time let's try 75 by 75 by 75. We'll press enter. So now this cube distance is going to, from the center point, it's going to extend that many Bohr in each of the x, y, and z directions. So if you enter 2 here, you'll end up with a cube of 4 by 4 by 4. In my previous case, that included a little bit too much, so I'm going to try 1.5 by 1.5 by 1.5, and we'll see if we can cut off some of the data that I had before. So now we have 1.5, 1.5, 1.5. We'll press enter. From here, it's going to generate your density matrix. I think it's a density matrix. So this one's much faster than the previous one. The last one took like 5 minutes to render with 100, 100, 100. So this one's a lot faster. So we'll wait a second here. While this is going, this is a good time to show in the manual kind of what we're looking at here. So as this is rendering, we'll kind of look here. So what we're doing now is we're defining this cube, and we specify, just like this midpoint between these atoms, and we're looking to map the hydrogen bond right here. And these will be mapped as a color gradient, where Blue shows a strong attraction. These are things like halogen bonds or hydrogen bonds. Green is a van der Waals attraction, and a red is a repulsive effect, right? So this is kind of the color map. And these correspond to this matrix down here, this sine lambda 2 rho by rho. So this is this reduced density gradient matrix that you get here, and these peaks correspond to interactions down at the bottom. So that's kind of what we're mapping here. So we can go ahead and look and see, now that our thing is finished, we can draw this scatter graph and compare what we have. So I do -1, press enter. This takes a little bit here, and I get this kind of funky graph here. It's a little bit different than what I had seen before, but I think because I'm defining my cube in a little bit different way, maybe I didn't include it, right? But we'll see what happens here. So from here, the next thing is I want to see the actual surface here before I map it into cube files. So press 7 to open up the GUI, and now I have to enter in an ISO surface. So they recommend in the manual 0.5, and so far that's been a good number. So do 0.5 here. We can turn off these things by hitting show axis and show atomic labels. Now we can get a little bit better view. We can't drag the same way, but here we can see our surface there in the middle. Let's zoom in a little bit. But this cube size looks like it succeeded, right, in omitting a lot of that other data that we didn't need. There's our hydrogen bond right here. And it doesn't look like it's showing the color yet because that's not been mapped onto the cube file, right? But we see what we need to see here right by the hydrogen bond. And now we'll put that into cube file, right? So we'll return out of here, and we need to make sure that we don't overwrite what we had before, right? So this is my folder. It looks like I already moved them, right? So we can go ahead and render them. So now the next option we need to select here is 3, output cube files to these functions here. So we'll press 3. It will put my cube files within my original folder. So I have my 2 cube files here. So what we need to do here is we need to find where VMD is located, and we need to put these files into the VMD folder here. So let me make sure that I don't have some files in here already, so it'll automatically be updated. So we'll go ahead and rename these something else. We'll name them like this. It's in my C file, so I have to give administrator access to everything. Move these, and we'll move my new ones over. So you can try to open these manually in VMD, but the author of Multiwfn actually wrote this script down here, rdgfill.vmd, and this is located in your wherever your file is for this Multiwfn. You can go in Multiwfn somewhere. Here it is. In your Multiwfn, you'll find an examples, and then this script is in this examples file. So you can copy this and paste it over into your VMD main directory. So once that's done, now we can open up VMD and we'll render this file. So it's top secret data, we can't show that. So now, once you have VMD open, we'll load his script as a visualization state, and that's automatically going to load in our cube files that we need. So we just need to find this rdgfill, double click that guy, and now it will open up our surface in VMD. So now we can see this, he uses a little bit different setup than me, but now we can see our nice NCI map right there, and it looks like our cube was perfect in this case because we have just the one that we're interested in here. It's blue, showing a strong attraction corresponding to a hydrogen bond here. So in VMD you can change these things, right? In graphics representations you can go and change the size of these bonds down a little bit. I like a 0.5 and a 0.1, and then you can raise up these resolutions here. So once that's done, now you have your new image. You can render this image. We'll go ahead and render this one with Tachyon. He also mentions in the manual that you select light 3, otherwise you might get some funky effects on your actual surfaces. So we also need to change this chlorine atom here to be chlorine colored. So we'll change him to lime. Okay, so now we're all ready. We'll get our image where we want it in the picture here. That's pretty good. And we'll go ahead and render this guy. So we'll hit File, Render, select Tachyon, browse my location to my folder that I want it to end up in. So I'm going to put it here with the actual file and my project. It's this method, and we'll just call it new only hbond.bmp. Get rid of that guy and render our image. Should take just a second. And now we can just double check what we have. Make sure everything is good. And that's how you render with the multi-wave function method. So yep, now we have our nice image here ready to go into a paper.